Hi, welcome everyone. So welcome to this A Year in Flink special edition, because I'm doing live coding, as Holger said. So first of all, I want to have a brief look at what happened over the past years. So if we look at the website visitors of flink.apache.org, we see this steady stream, like from 2016 to now, there has been a steady stream of increased users. Like basically, if you look at it very closely, you will see this quite steady stream up until, let's say, the second half of 2018, and then it ramped up a bit. So from that, there seem to be quite a lot of users that look into Flink, that work with Flink, and that are using our website as a useful resource. Then when we look at things like what happened from the development side of things, just in September last year, Flink 1.9.0 was released. So that's a bit out of this last year scope. But since then, a lot has happened. So there have been two major releases, like Flink 1.10 came out in February, Flink 1.11 came out in July. So roughly speaking, a Flink release or major release every 5 months. And the Flink developers have not only been focusing on Flink, or the core Flink distribution, but also released the stateful functions library into the open. So in April this year, the stateful functions API became part of the Apache Software Foundation, and the first release was created then. And the stateful functions is actually a bit on a faster pace, so delivering you more up-to-date, more recent features as it is being actively developed. But wait, I collected those statistics manually, like by hand. But why? Why should I? It would be better to automate this, right? And this is actually what I want to do for the rest of the talk. So let's look at something that gives us those statistics in a better way, so that I don't have to work on those by collecting data manually. And for that, I chose to have a look at Flink SQL, because its focus is on logic, not on the implementation. And it is both available or both useful for batch processing as well as stream processing. It aims at maximizing the developer speed and the autonomy of the user, and thus it should be useful in getting quick results and exploring your data, and at some point also getting into full-fledged streaming applications. So what is Flink SQL, in case you haven't dug into it yet? Flink SQL is, well, SQL on its own is a declarative API. So on the left-hand side, you see this statement, and what Flink does, if you give it that statement, it will basically translate that into a job. So a job in terms of Flink is a composition of some operators that exchange data, and eventually, well, you start reading from something, then you do transformations, and eventually you have something that you put on the output. So that's this streaming graph that the SQL query will be translated into. So it defines a program. It's not a database, it's just a way of defining a program. It can also be used to get materialized views and to get the maintenance on that for free. So take this example. It has an input table of transactions, and we want to have a Flink job that is doing some aggregation. Like this job is going over the transactions table, and we'll just count the transactions and group them by type, and then get the counter that you can then use to serve dashboards. So that's a common use case for Flink SQL as well. You will get your real-time dashboards updated by a running Flink job. And what is there at the moment to work with Flink SQL? Well, you can write your Java code or Scala and just embed SQL in there, and or use the table API, and then send this query out, execute, and the rest of the translation will be done. You can also use the SQL query, the SQL CLI, and have it on your command line. Just do the queries that you like, and then put them out. Both of them are not really viable for production systems, and this is why we at Ververica chose to integrate SQL into our platform. So at the core of the platform, there's this strong Apache Flink streaming runtime that you used to know. And then we have very useful and easy tooling around that helps you get your applications deployed, that helps you create your clusters and manage them over the life cycle of those applications. And we started with support for Java and Scala jobs. We extended this now basically by releasing the 2.3 version yesterday. We extended it with support for SQL. So I thought, why not use it? And you can use SQL with our platform in basically two ways. One is you use the integrated editor. So there's a SQL editor in your browser that shows you the platform, and then it can interact with the platform. It can look into the catalog that the platform comes with. It can you can upload UDFs, so user-defined functions or define tables, and then those will be translated into queries that will then run in your cluster. All of that is using Kubernetes underneath, but that's nothing you should worry about. The other way to interact with or to use SQL with our platform is by using Jupyter Notebooks. I'm going to use the IDE in the browser. So let's have a look at what we can do. To gather a few more statistics, let's switch over to the platform. Sorry. So what I did in preparation for this event is that I created or imported a bit of data so that I can use that to analyze it. So what I did is I queried the GitHub API and fetched the commits in the Flink repository, and I also fetched all the pull requests, and I also imported the mailing lists like the user and dev mailing lists so that we can have a look at those and see what was happening on them. So those I did beforehand. So we have a bunch of Kafka topics that are now pre-filled with data that we can use to do our analytics. And if I look into, so now we're going into SQL. This is the SQL editor of our platform. To the left, you will see a Schema Explorer that you can use to get information about everything that is in the catalog that comes with the platform, or with the Hive catalog if you connect to that. So I chose the internal platform, the internal catalog. And as you can see, I have a bunch of tables available, and we will make use of them throughout the rest of this webinar. So, and I also have a bunch of functions that I will use at a later point. So I want to talk about what happened in the Flink community. And well, just as a starting point, let's take the user mailing list as an example. So I do have this one table that is Flink mailing list user. And if I look into that, I will see a bunch of things that I imported from the Mbox archives that you can download. It's the date of each email that got into the mailing list. It's the from field, also passed as an email address, and it's the subject. I don't need the body for the rest of the analysis, so I just skip that, but it could have been imported as well. So let's do our first query. Let's try and gather some information. We could look for the number of users on the mailing list. So we say a select, let's say star from, and now we have this Flink ML user. And I could just do that. Let's see. Let me close that preview. Let's just run it and see what's being read. So now I get all those email addresses, but I don't want all of them. I mean, it would be nice to know how they change, how those numbers changed over the time. So what I want is to have maybe an overview of the user count over maybe months. So this is what you can use a tumbling window for. And in SQL, it just goes by group, by, and then tumble, and you specify a time attribute that you can work on, and that is some timestamp that you can use. And if I look into the table again, there's this date column. And in that date column, we have the date of email, so we'll use that. So I have a tumbling window over the date, and now I need to define the length of that tumbling window, and in SQL that goes with the interval, and let's make it a statistic over 30 days. So roughly a month, 30 day. So now I do have a tumbling window, but I'm grouping by, so I cannot just select star. And let's make it a count. I want to count everything that happened in that window, and maybe I also want to know which month I counted this for. So I do maybe tumble end, so this will get me the end timestamp of that tumbling window of those 30 days. And for that to happen, I need to use the same specification that I did down here. I say I can have this tumble end, and I will rename it to window end. And the count star is as maybe num users. All right. Now we should be good to go, except for, well, this is not actually counting the users. So how is a user defined? So if I just cheat and click into the table again, I can see what I have, and I could distinguish the users from the email addresses. And this is what I'm going to do. So by having the distinct number of email addresses, this is how I get the number of users. So I will just count the distinct email addresses. So that's just in the from email field. And distinct from email as, oops, I'm missing a letter. That. And now I should be ready to go. Let's close that again. Just run that to see a preview. There we go. I see all the months aggregated. There are actually 2 windows here. I imported everything from the mailing list since the start of those mailing lists in 2014, when Apache Flink became an Apache project. But the talk is just a year in Flink, so we want to do this only for the past year. So let's actually reduce the scope a bit. So let's say where my date timestamp is greater than, let's use the current timestamp. So current timestamp gives you the current timestamp, and I want to look back a year. So I will remove an interval of 1 year. There we go. And then we should only get everything that happened in that past year. So let's run it again. And I do get everything starting roughly a year ago. So that's the window ending in the 10th of November. And then 30 days after that, and after that, and after that. So I would have 12 results there. Cool. So that's the first statistic that I get. This is the number of distinct email addresses per month on the user mailing list. Let's do something more. Let's maybe count or have a look at the emails. So how many emails did we get on that email address, this mailing list? So instead of counting the distinct email addresses, I just count everything, and it's not users anymore. It will be a number of emails, and that's actually where I can already start. Right? I count everything. That's the number of emails. Let's see. There we go. There's a steady stream. If we look back, it's like around 500. Some periods have been lower, some periods have higher numbers. There has been some more activity in the month up until the start of March. Maybe that's related to the Flink release that got out then. We don't know. We could have a look further. There's a second one in May. But this is actually just the number of emails. I would actually like to have a better look at things like how engaging were those. I mean, just looking at the number of emails, it could be something like users are just sending them but never get a reply. So I actually want to have a look at email threads that happened in that month. So how do I distinguish those threads? Let's have a look at the table again to see what the data model is. And I do have the subject in here. And usually when someone replies to a subject, to an email, this subject is prefixed with re. Or maybe in other languages there's some other prefixes, but let's just stay simple at the moment. We will assume that it is a prefix with this re, colon, and then a space. So we want to count the distinct email threads. So count again, we'll just distinct, and we will try and remove that re prefix from the subject. So we will trim the leading, then re colon space from subject. And as you can see, there's already some syntax highlighting when I don't type, or when the whole SQL query is not correct, I do get the errors live. So I can see what is wrong, and I can then act on that. So I have the distinct, I'm counting the distinct subjects, removing every RE. So that should give me the email threads. Let's see. Let's just rename this. It's not the num emails, but the num threads. That should be fine. Let's run it again. Close that. All right, there's some threads. It's a bit fewer than before, but we don't have both numbers at the same time. So let's actually make a result. This is just a preview. Let's make a result that gets us both the emails as well as the threads. And I removed the previous statements, so I will just undo that, all those changes. And we'll have two things here. So at the moment, I was just looking at emails, and I was separately looking at the email threads, but let's bring them together. I have two queries. One is the one for emails, and the other is the one for the email threads. So by bringing them together, I get the overview, and I'll do that by making each of them a temporary view. So create temporary view, and then I give it a name. Maybe that's the emails as, and I'll group that together like here, and then have a second view, create temporary view, and that's the threads as, and oops. So now I have two temporary views, and I just need to bring them back together. So for that, I can just join them all together. I can, for example, select, let's make a select star at the moment, and I want from emails as well as, or as maybe rename it to some short thing, and as well as threads T, and I will join them on the month, because both of them aggregate everything on a windows of 30 days. So I can group them both together on exactly that attribute, that window end that is there in both. So I will do where e dot window end equals t dot window end. And then let's just rename a few things so that we have it easier. I will want this window end. I know it's the same, so I'll just want it once, window end. Then I also want the number of emails. So this is the one that I have at the topmost view. And then as the second thing, I want the number of threads also in here. So now we can actually run that. That should be maybe emails.window end, and I can run the whole thing. And it would give me the emails as well as the threads. But what I actually want to look at is how engaging were those threads. So what I want is to know how many emails were there per thread. And I'll just add that field. I'll make number of emails divided by num threads. There we go. Start it again. And well, we didn't give it a good name, but there's some low numbers. Sometimes actually also saw 0. And there's one thing to be aware of. This is SQL. So both num threads and num emails are integers. So the calculation, this division, is actually integer division. But what I want is a float division. So I want to have the exact average number. So I can do things like cast this type to float. And then it will be floating point division. And then I will get better results. We can make it as maybe average, or as emails per thread. So we have it a nice name. And we already saw in the preview that there are some values which were not at 3, but rather 3.9. So we want to know that distinction. So if we browse through those engagements, we see, like, say, roughly, but at the roughly 4. So almost all of them can be rounded up to 4. And so they're, on average, 4 emails per thread. That's fine. Let's maybe also look at another mailing list. I did import different mailing lists. So I also used these, imported the Chinese mailing list. Let's have a look at how things are there. So I'll just change those from tables, because I also have this FlinkML user China. It has the same format. I can see that in here. If you actually look a bit further, for example, at the DDL statement, this is how I created that table. So I have the fields that we saw in the columns, and I also defined a watermark for that date so that we actually are working in event time. All right, let's see. Let's see what the result is for the Chinese mailing list. And behind the scenes, Flink will execute that. It will walk through the Kafka cluster, and we'll have a look at this later at a bit more complex query. So for the Chinese mailing list, it's almost the same. Maybe one email lower, so roughly 3 emails per thread. All right, let's have a one more details. Let's get more details. Sorry. I want to, well, now we looked at the user mailing list. We also looked at the user mailing list in Chinese. Let's actually have an overview over all 3 mailing lists that I imported here. So that is those 2 as well as the dev mailing list, and let's compare them all together. So we do have a temporary view on the emails. For the Chinese user mailing list, let's make it one more for the normals, so we can just rename them. This is Chinese mails. This is normal Flink user or English Flink user, and then we have dev. So that is also Flink dev, and we can have a look at the table definition, and it's just the same. All right, now I have temporary views of all those 3 email addresses. I just need to join them together. So I'll do that below here. So we already joined 2 tables, but now it's actually let's move that a bit further away. I want to join those 3 email tables together. So let's make a select star. Let's start with a select star. And I want to join from emails ZH, as well as make it EZ, emails Z, as well as, what is the other, emails dev D. And I want to join those 3 tables together, and I just need to define what they are joined together on. So this is where ez.window_end equals e.window_end, because they're all the same from what you can see above. And then the second thing is e.window_end equals d.window_end. All right, and then just maybe rename a few things so that they are more speaking to us. So we can have well, let's just start with a window end, so we always see what window this is for, and then we'll go with what did we have? Num emails as user, or maybe it's user. Then we have ez.num emails as user ZH, as well as d.num emails as dev. Oops. There we go. We combined all of them together, except for this one thing here. Encountered a colon when there shouldn't be. Let's see what I forgot. There's one. Yep, that should not be a comma. That should be an end. That's a where condition. How lucky we are, we actually got real-time query validation. So we see when something is wrong before we actually get this query into the cluster. All right, let's execute this. I'll just execute that selection because I only want to execute that part, and the other part is just stored away for later. I just run. All right, now we see all the months. There are like something like 500 emails on the user mailing list. On the Chinese mailing list, there have been 800. So it also looks like this Chinese mailing list is quite popular compared to numbers. And the dev mailing list is equally as well used. So let's maybe have a look, or a deeper look at the dev mailing list to continue that. Or maybe actually, this is a more complex query. Let's see how it is translated inside. So we'll look at the session cluster. Session cluster. This is the cluster that the Vertica platform will use in order to execute those previews. So we'll have a look in here. Remember, we joined 3 tables together, and we joined all of them together on their time attributes. So that way, Flink can internally also throw away things when they're not needed anymore. I cancel, actually, sorry. I did cancel that preview, so I cannot see anything anymore. So I actually need to run that query again because it's just a preview, and a preview, if it's not there anymore, it doesn't need to be running. Right, session cluster. Actually, we have that Flink session cluster still here, so we can just refresh. We should see the new jobs popping up. And now maybe the live demo is abruptly getting to an end. Because, no, there it is. Okay. Let's see. So this is the cluster, or this is the job that Flink translated the SQL query to. So we can browse, we can zoom in and have a look at the things it does. So there is a table source that will read from the, what is that? I don't see it immediately. There should be one for each of the tables. Like one is here, the other is here, and the third one is down here. Then there are some filters, there are some aggregations. There are also some reductions because we don't need everything. We, for example, didn't make use of the email from fields and other things, so those are being dropped. So there's an optimizer running behind that would reduce this query to perform better. All right. Now that we have an overview of the mailing lists, I wanted to have a deeper look at the dev mailing list. So let's choose that. So email threads per month. This is what we used earlier, and we'll use the same thing for the dev mailing list. I do have this emails. I can just adapt this for the dev mailing list. I once had the threads that are there for the dev list, and I can just combine those two together just like we did before. So I want to join the emails and threads, and up until we're going to an end. So I will just switch over that part, and we'll show you the one more advanced statistic that I wanted to pull off to just get you into the mood, basically. So I prepared a little bit some of the scripts that I wanted to show. I stored them in the platform so we can have a look immediately. I stored them in here, and what I wanted to have a look at is who had the most commits. So who was the most active in terms of commits into the Flink master branch over the past month. So I prepared the query. I will actually get it running first. So this one we cannot preview at the moment because it's not an append-only stream. For those who know Flink SQL, the preview is currently only capable of running or showing append-only streams. So that one is, I will just go back to the editor to see it is a retract stream, so that I cannot immediately show, but it will be running behind the scenes. I just started up a deployment, and this is what will be done by a live stream application, and then it will update something. In that case, for me, it will update an index in Elasticsearch. So I use that table that will put something into Elasticsearch, and I can browse that once it is running. So I'll just show that real quick once it is running. Or maybe I can take a few questions up until I have the result, and then I'll show you that. Then let's have a look at if we still have a minute, let's have a look at the result of that query. And I put this into Elasticsearch, and let's see who had the most commits last month. So in the 30 days up to October the 5th, this famous, I sorted this by author email addresses, this famous null email had 160 commits. So congratulations to null. That might be something from the GitHub API. Maybe this is from those privacy settings that you can actually say you don't want to reveal your email addresses. So let's look at the second one. Stefan Even with 32. And then David Wyszakowski, sorry, with 16. And then a few more. You can look at those. I just printed or put the top 5 in there. So just to see. Thank you.